Okay, students, welcome to Tuesday's video, the 30th of April. A couple quick announcements. Please don't forget, Chase and Matthew, you guys owe me a test and a quiz on Thursday. It is due that day, so if you do not turn it in, you will lose some bonus or some points, and I will let your parents know, so please make sure you take care of that. If you have questions on the videos or anything that's not working, I don't want to know about that on Thursday. I want to know about that right away. So call me, email me, something, and I will help you. That's my job. I don't mind doing that. Okay, we are going to quickly review. We always try to review the previous day's material, okay? I know that can be a little annoying, but it's very important that we always try to keep this stuff fresh in your mind. So if you'll notice at the top of your, well, if you've not printed your handouts, go ahead and stop, print your handouts, and then go ahead and restart the video. But if you'll notice at the very top of your page, we're going to graph this function right here. It's already on your notes for you. Y equals 2 over 1 plus 0.4. I'm just going to put 0.4 e to the negative 0.3x. All right, let's graph this. We learned how to do this yesterday and Monday. I'm going to quickly list out my C, A, and R. C equals 2, came from right there. A equals 0.4, the coefficient of the E. And then C is the coefficient of the x, but you always change the sign. So instead of putting negative 0.3, I'm going to put a positive 0.3. There we go. Okay, step 1 said to list out your horizontal asymptotes. We have horizontal asymptotes at 0 and 2. All right. Oh, by the way, if you want to pause now and do this for a bonus point, I have no problem. I forgot to mention that. So feel free to stop the video and do the rest of this. If you get it right completely, you can have a bonus point for your account. If you just want to watch me, that's up to you. So continuing on, there's your horizontal asymptotes, 0 and 2. The next thing in your notes said to use this formula here, natural log of A over R, comma, C over 2, to find the middle value of your graph. So we would have the natural log of 0.4 over R, and I don't know why I put a C up here again. I'm going to erase that. Should be R equals 0.3 R. Anyways, so then over 0.3 and then comma, C is 2 over 2. So let's go ahead and type this into our calculator. If you were to, and I've actually got to reach for mine, don't have it turned on yet. Always helps to turn it on. Okay, let's go with the natural log of 0.4, so natural log of 0.4, and you should get negative 0.91629, then divided by 0.3, divided by 0.3, and you should get this right here. I'm getting out negative 3.054, comma, and then 2 over 2 is just 1. So there's our middle value. Okay. Now the next thing that our note said was to type the function here that I'm circling into your grapher. So you would hit y equals, and then 2, and then hit divide, then put a parentheses, and then 1 plus 0.4, then hit the E button, so the E pops up with an arrow and then part of a parentheses. You would type in negative, not minus, but negative 0.3x, and then close your parentheses twice. Okay, so make sure you've typed that in correctly. And if you have typed it in correctly, you're ready for your table of values. So here we go. In the middle, we're going to put negative 3.1. That's good enough. Negative 3.1 and then 1. So I'm going to go to a negative 2 and a negative 1, and then this direction a negative 4 and a negative 5. Okay, so looking at your calculator, you might have used some different values, but that's pretty close. Negative 1 is negative 1 is 1.3. Negative 2 is 1.2, 1.15, 1.2, and of course negative 4 would be 0.86, and then negative 5 would be 0.72. All right, there we go. So let's go ahead and go like this. Let's go ahead and graph this. If we can't drag this over here like that. All right, here we go. Now we have horizontal asymptotes at 0 and 2. So not going for the neat award today. 0 and 2, so you should have horizontal asymptotes going through there. And then our first order pair is negative 1, 1.3, so negative 1, 1.3. And then next would be negative 2, 1.2, so negative 2, 1.2. And then next would be negative 3.11, so negative 3.11. So it's really kind of skinny here. And then, let's see, next we have negative 4.86, so right here. And then negative 5 would be 0.72, so kind of like this. So, always start at the middle. Looks like this one's going to be really skinny, and it's going to go up slower than the other ones did. And that's okay. You can curve it a little bit right there so I can see it's not a straight line. And that's good. That's good enough, okay? You know whether or not your table of values is right and if your asymptotes were right. So either you followed me along or you got the extra bonus point. That's totally up to you. All right? Okay, let's continue on. You should have your notes printed. So if you'll take a look at the first page there, the heading says Solving Logistic Growth Functions. Solving logistic growth functions. And I've given you two steps to solving these logistic growth functions. And the first step says you want to eliminate the fraction by multiplying both sides of the equation by the denominator. Okay, that's step 1. Just reading along from your notes, you can follow along. And step 2 says, step 2 says now solve the exponential function. And if you want to write this in your notes there next to that step 2, you will find that in your notes right here. If you look at the video, page 68. So that's a previous handout all the way back to last Monday. We learned how to solve exponential equations. And we're going to be using these steps right over here. So step 2 says this. It says now solve the exponential equation. And so we've learned how to do that. And if you need help, turn back to page 68 in your notes and you'll see the steps right here. You see my mouse going over the steps. You'll see the steps for solving an exponential equation. Okay? All right, so let's continue if we can't solve a couple of these equations. 3 of them, then I've given you 6 for your homework. Okay? All right, well, let's get after this. See how we do. We have this function right here in your notes. 50 over 1 plus 10e to the negative 3x equals 40. Now, step 1 says to multiply both sides of the equation by the denominator. So, in black, I'm going to circle your denominator. There it is. Do you see that? We're going to multiply both sides of the equation. Or we'll do it this way. We're going to multiply the entire equation by 1 plus 10e to the negative 3x. Now watch what happens. Just watch. I'm going to put that over 1. We're going to multiply whatever the denominator is. Do you see this? Whatever the denominator is, we're going to take that and multiply it through the entire equation. Now here's why you do that. Watch what happens. When you take this times this side, notice this whole top right here cancels with this here, leaving you with just 50 on the left side. Now when you multiply 40 by all of this, you would get this right here. 40 times 1 plus 10e to the negative 3x. Now we're going to do 3 of these, so relax. I know it's not super easy to see at first, but just watch. So whatever your denominator is, you multiply both sides of the equation by that denominator. Now the reason you do that is on one side of the equation, it will completely cancel out your denominator, leaving you with just the top, which is 50 in this case. Now over here, we're going to take 40 and multiply it by the same thing, and you're going to see in a second it's really not that difficult. 40 times 1 is simply 40, and then you have a coefficient of 10, so 40 times 10 would simply be 400 e to the negative 3x. Okay, so there we go. We did it. We did step 1. Step 1 says to multiply both sides of the equation by the denominator. We've done that. And now step 2 says solve the exponential function. Solve the exponential function. Now let me refresh your memory, okay? In fact, earlier I put these steps up in the video for you to see. Remember, you isolate the base and its exponent. You'll find this on page 68 in your notes from about a week ago. Then you take the log of both sides. then simplify both sides, and then solve for x. So if you need to continue to see these steps, then go ahead and open your notebook to page 68 and have these steps off to the side. That's where organization and having things, in order really comes to help you. All right, so we're going to solve this exponential equation. So we multiplied both sides by the denominator, we got rid of our fraction, and now here's what we do next. Remember, anytime you want to solve an exponential equation, here's the exponent, here's the base. You want to get that whole group all by itself. So you want to get rid of the 40 and you want to get rid of the 400. You want to get rid of both of those numbers, okay? So I'm going to first of all subtract 40 from both sides. Subtract 40, subtract 40, and now I'm left with 10 equals 400 e to the negative 3x. Now next, I'm going to divide both sides by 400. So divide this side by 400. Divide this side by 400, and I'm going to have to continue this on the next page, which is fine. Okay, we're going to divide both sides by 400. These cancel out, and we're left with e to the negative 3x. And of course, over here, I'm left with 1 over 40 if you reduce it, 1 over 40. Now, you should know what to do next. We've isolated the exponent, we've isolated the base. We can see that we have an unknown here, up here in the exponent with a base. So remember, we're going to take whatever this base is right here, we're going to take log base e, log base e. Now the reason I chose e is because of this right here. Whatever that base is, that's what I put here and here. That should ring a bell from about a week ago Monday. So log base e of this whole left side, so 1 over 40. Log base e of this whole right side, so negative 3x. Now we did that because actually I need to fix that real quick. It would be, sorry about that, e to the negative 3x. You bring down this whole right side. Now, the reason we've done this is your base is matched. So whenever your base of a log matches the base of the exponent, everything else cancels out except the exponent. And then we bring down log base e of 1 over 40. And now divide both sides by negative 3. And so, actually, I'm going to go ahead and make this a decimal real quick. It'd be a lot easier. Hey, students, remember what log base e is? Look over here. Remember log base e is the exact same thing as natural log. If you've forgotten that, I'm sorry, but I've taught you that. Log base e is the exact same thing as natural log. So instead of log base e, I'm just going to go ahead and write natural log of 1 over 40. That makes it a little easier. Now before you divide by negative 3, let's go ahead and get our decimal over here. So let's type in the natural log of 1 divided by 40, negative 3.69. So negative 3.69 equals negative 3x. And now divide both sides by negative 3. Divide both sides by negative 3, and you'll get 1.23 equals x. 1.23 equals x. Let me quickly check that answer and make sure that is right. Yes, that is correct. Okay, so there we go. You just solved your first logistic growth function. Not that bad. And those are the steps that you would use. Let's do 2 more in your notes. I'll tell you what, after I do 1 more, if you feel like you're ready to go ahead and start your homework, you can skip the 3rd example. I'll leave that up to you. And then you have 6 homework problems to do. All right, so here we go. Here's the equation that we're going to solve. Let me back that up over here. Let's put it in the middle. It's 18 over 1 plus 2e to the negative 2x equals 10. There we go. Okay, we're going to solve this logistic growth function. Well, remember the first thing we do is we multiply both sides by the denominator. So both sides will get multiplied by this right here. Sometimes it helps putting it over 1 so you can see it a little better. Well, this would cancel with this, all right, and that would leave you with 18. And then we must also multiply this with the 10, so we would have 10 parentheses 1 plus 2e to the negative 2x. There we go. All right, and now we can simplify this right side. 18 equals 10 times 1 is 10, and 10 times 2 is 20 e to the negative 2x. And now we're good to go. Let's solve this exponential equation. Remember, this is my exponent. This is my base. So I want to get those things there all by themselves. So I've got a 20 to get rid of and a 10 to get rid of. Okay? So let's first of all subtract 10 from both sides. Subtract 10, and 8 equals 20 e to the negative 2x. Next, we're going to divide both sides by 20. If you divide the right side by 20, the 20's cancel. You're left with e to the negative 2x. If you divide 8 by 20 and reduce, you will get, let's see, 2/5. 2/5. All right? And now remember how we have this base e? I'm going to finish this problem right up here. We're trying to solve for an exponent that has a base e. So remember, we write log base e equals, leave a little space there, then equals, then log base e. Now, the left side is 2/5, so I'm going to put a 2/5 right here. The right side is e to the negative 2x, so I'm going to put e to the negative 2x. Now, I did that because look at the right side. My base matches my base, so everything cancels out except your negative 2x. And over here, remember, log base e is the exact same thing as natural log of 2/5. So natural log of 2/5. Let's type that into our calculators. Natural log of 2/5 equals negative 0.916. Negative 0.916. And now divide both sides by negative 2. So divided by negative 2, and your answer is 0.458 equals x. And let's continue on. One more problem in your notes. If you want to skip this next problem and go on to your homework, that's totally up to you. I will leave that discretion up to you. All right, here we go. We have 30 over 1 plus 4e to the negative x equals 9. All right, so let's go ahead and multiply the entire equation by the denominator. 1 plus 4e to the negative x. Of course, these would cancel, leaving you with just 30. And on the right side, I would have 9 parentheses, 1 plus 4e to the negative x. Now, let's go ahead and take our 9. Let's multiply it through. 9 times 1 is 9. And 9 times 4 is 36. E to the negative x. So there we go. And now let's go ahead and let's solve this exponential equation. Here is your exponent. There's your base. We're going to get those two things all by themselves. We have a 9 to get rid of and a 36 to get rid of. All right. So let's first of all subtract 9 from both sides. Subtract 9, subtract 9. And we're left with 21 equals 36 e to the negative x. Now let's divide both sides by 36. When you divide the right side by 36, you're left with e to the negative x. When you divide the left side by 36, you're going to get 7/12 if you reduce correctly. 7/12. Okay? And now look at your base. Here's your unknown. It's an exponent. Your base is an e. So whatever your base is, in this case it's an e, we write log base e. Leave a little space. Log base e. Do you see this e right here I'm circling? If that would have been a 2, then you would put a log base 2 and a log base 2. It all depends on what this base is right here. So log base e, then bring down your 7/12, and then bring down your e to the negative x. Now we're going to finish this right over here. Remember, on the right side here, whenever a base matches a base, everything cancels out except the exponent, so negative x. And then over here on the left side, log base e of 7/12. Remember, that just means the natural log of 7/12. The natural log of 7/12. So natural log, let's see what we got here. Natural log of 7/12 would be negative 0.539. So negative 0.539 equals negative x. That's really a negative 1x, so we divide both sides by negative 1, and your answer is 0.539 equals x. All right, that's been a pretty fast lesson. I've not taught for that long at all. I've given you 6 problems to work out. I do want your homework done. It's mandatory. So page 521. numbers 36 through 41. Actually, I've given you 6. Yeah, 6 problems, 36 through 41, all of those. All right? Let me get a quick drink of water, and I'll work these problems out for you. Now, remember, it's your choice. You are more than welcome to watch the entire video or try these on your own and then go back and check them. That's totally up to you. So here we go. Let's start off with number 36. Number 36 is, here we go, 8 over. Is that one that we just did? No, it's not. Okay, good. 8 over 1 plus 3 e to the negative x equals 5. All right, let's go ahead and multiply the entire equation by your denominator, which is 1 plus 3 e to the negative x. This will cancel with this, leaving you with 8. And over here on the right side, we would have 5 parentheses 1 plus 3 e to the negative x. Now I want to warn you, I'm getting really close to skipping this step here where I put the 5 in the parentheses and then multiply the 5 through. So I'll probably do one more problem like this, then I will skip that step and I'll just start writing this instead. 5 times 1 is 5 and 5 times 3 is 15. Okay, so we should be getting pretty familiar with that by now. So 5 times 1, 5 times 3. And now let's continue on. We're solving an exponential equation. Here's your exponent. Here's its base. So we're trying to get those all by themselves. So we have a 5 and a 15 to get rid of. So with that in mind, let's subtract 5 from both sides. Subtract 5, subtract 5. We're left with 3 equals 15. E to the negative x. Well, right away now we divide both sides by 15. 3 divided by 15 is 1/5. And when we divide 15 over here, divide this side by 15, the 15's cancel, leaving you with e to the negative x. All right, so here we go. We have a base of e with an unknown for an exponent, so I'm going to take log base e of both sides, log base e of 1/5, and log base e of e to the negative x. Well, let's go ahead and finish this right over here. Log base e of 1/5 just means the natural log of 1/5. Okay, don't forget that. Log base e is the exact same thing as natural log. And then also, over here on the right side, whenever your base matches your base, you're left with just the exponent, so negative x. So there we go. And then let's go ahead and type into our graphers the natural log of 1/5. And the natural log of 1/5 would be negative 1.61. Good enough. Negative 1.61 equals negative x. So we divide both sides by negative 1, and our answer is 1.61x. All right. Hopefully, little by little, you're getting some confidence. These are not that easy. You just got to practice. All right, number 37, logistic growth equation. We have 1 plus 2e 10 over 1 plus 2e to the negative 4x equals 9. All right, let's go ahead and multiply both sides, or the entire equation, by the denominator, which is 1 plus 2e to the negative 4x. This would cancel with this, leaving you with just 10. And over here on the right side, this is the last time I'm going to do this step for you here. And then from then on, I'm going to skip this step, 2e to the negative 4x. There we go. So let's take our 9, let's multiply it through the parentheses. 9 times 1 is 9, and 9 times 2 is 18, e to the negative 4x. All right. Now, if we want to get the e and its exponent all by itself, we have a 9 and an 18 we have to get rid of. Let's subtract 9. Subtract 9, we're left with 1 equals 18, e to the negative 4x. Now let's divide both sides by 18. So 1 divided by 18 is 1/18. And over here, when you divide 18 by 18, they cancel, and you're left with e to the negative 4x. Now, we have an exponential equation with a base of e. So whatever this base is right here, in this case it's an e, you take the logarithm with that base of both sides. So log base e, log base e. Log base e of 1/18 and log base e of e to the negative 4x. All right, we're going to finish that right up here. Now look at my pen. Do you see this? Log base e is the exact same thing as natural log of 1/18. And on the right side over here, whenever a base matches a base, Everything cancels out except the exponent, so negative 4x. And now let's quickly type in the natural log of 1/18th. And if you do that, you will get negative 2.89. Negative 2.89 equals negative 4x. And now let's divide both sides by negative 4. And you will get 0.7226. 0.7226. And you guys know me well enough by now to know that I don't, it doesn't matter where you round. That's kind of your decision. All right, let me get a quick drink of water. And now we're moving on to number 38. Number 38. All right, number 38. After this, we'll be halfway done. So we're cruising along pretty quickly. 3 over 1 plus 18 e to the negative x equals 1. Okay, let's go ahead and multiply the entire equation by the denominator. 1 plus 18 e to the negative x. This would cancel with this, leaving you with just 3. And on the right side, we would have 1 times 1, which is 1, and then 1 times 18, which is 18 e to the negative x. Okay? And I did tell you I was going to start skipping that step. So if you need to write that extra step in, feel free to do that. It's up to you. Okay, it looks like I have an e and a negative x. They're grouped together. That's my unknown. That's the base. So I have to get rid of my 1 and my 18. Let's subtract 1 from both sides. So we're left with 2 equals 18 e to the negative x. Now we'll divide both sides by 18. 2 divided by 18 reduces to 1/9 equals e to the negative x. And now I have an unknown exponent with a base of e. So I write log base e, leave a little space, equals log base e. Bring down your 1/9, bring down your e to the negative x. And now if you look at your right side, whenever a base matches a base, you're left with just the exponent. And over here, log base e of 1/9 is the same thing as the natural log of 1/9. So the natural log of 1/9 would give you negative 2.197. So negative 2.197 equals negative x. So divide both sides by negative 1, and that would be 2.197 equals x. You might have rounded to a totally different place, which is fine. That's totally your decision. Moving on, let's take a look at number 39. Number 39. All right, here we go. Number 39 is 28 over 1 plus 13e to the negative 2x equals 20. All right, let's go ahead and multiply the entire equation by 1 plus 13e to the negative 2x. All right, so this would cancel with this, leaving you with 28. And then on the right side, we would take 20 times 1, that gives you a 20. And then also 20 times 13, and that would give you a positive 260 e to the negative 2x. Okay? So 13 times 20 would be 260. Now, we want to get, I have an exponential equation. My unknown is in the exponent. I have a base of e. I want to get this group right here all by itself. So we have a 20 to get rid of and a 260. Let's subtract 20 from both sides, and we're left with 8 equals 260 e to the negative 2x. Now we're going to divide both sides by 260. When you divide the right side by 260, the 260's cancel, leaving you with e to the negative 2x. 8 divided by 260, wow, what would that be? That would be, let's see, 4 over 130, 2 over, I believe you get 2 over 65. I had better check that. Let's see, 8 divided by 260. 2/65. Yep. All right, so this is 2 over 65. Now let's move on. Notice I have an unknown with a base of e, so right away I realize I've got to write log base e, leave a little space, log base e. Now bring down your entire left side, which is 2 over 65, and over here bring down your e to the negative 2x. Now on the right side, whenever your base matches your base, everything cancels out except your exponent, negative 2x. And over here, log base e is the exact same thing as natural log of 2 over 65. So let's quickly type in the natural log of 2 divided by 65, and we get negative 3.481. So negative 3.481 equals negative 2x. Now we'll divide both sides by negative 2, and we will get 1.741. 1.741 equals x. And wow, 4 down, just 2 left to go. So next to last problem. We're almost done. All right. Okay, number 40. 82 over 1 plus 50 e to the negative x. 1 plus 50 e to the negative x equals 68. Okay, let's go ahead and multiply the entire equation by the denominator, which is what step 1 says to do. So 1 plus 50 e to the negative x. And by doing that, this would cancel with this, leaving you with 82. And then we take 68 times 1, which would be 68, plus, and then 68 times 50. That would be 40. I'm getting 3,400. I'm going to check that with my calculator in just a second to make sure that's right. 68 times 50. Yes, 3,400. Okay, and now look what we have. We have an exponential equation. And so we have an unknown in the exponent. The base is e. So I've got a 68 and a 3,400 to get rid of. So I'm going to subtract 68 from both sides. And when I do that, I'm left with 14 equals 3,400 e to the negative x. All right, 14 equals 3,400 e to the negative x. Now, if we divide both sides by 3,400, 14 over 3,400 would reduce to 7 over 1,700s. And then over here on the right side, I'm left with e to the negative x. So what I did is I divided both sides by 3,400. Now, look at this. I have a base, and it's unknown. The base is e. So I'm going to take log base e, leave a little space, log base e. Okay, bring down the whole right side, e to the negative x. Bring down the whole left side, 7 over 1,700. All right. Well, whenever a base matches a base, the whole thing, these cancel out, leaving you with just the exponent. And then over here, log base e, don't forget, really means the natural log. So log base e means the natural log of 7. Let's type this in. Natural log of 7 divided by 1,700. And that would give you negative 5.49, negative 5.492 equals negative x. So divide both sides by a negative 1, and your answer is 5.492 equals x. Wow. I got a little bit of a headache. One more and we're done. Number 41. All right, number 41. All right, 36 over, where are we at here? 36 over 1 plus 7e to the negative 10x equals 30. All right, let's go ahead and multiply both sides by the denominator. So 1 plus 7e to the negative 10x. And of course, these cancel, leaving you with just 36. Then over here on the right side, we have 30 times 1, which is 30. And then 30 times 7, which is 210 e to the negative 10x. Okay, so 30 times 1, 30 times 7. And now we have an exponential equation. Here's my unknown. My base is e. So I want to get all of this isolated all by itself. So I'm going to get rid of my 30 and my 210. First of all, I subtract 30 from both sides. So 6 equals 210 e to the negative 10x. And now we divide both sides by 210. So make sure my headphones are still working. Just kicked them. There we go. All right. So let's divide by 210. And 6 divided by 210. If you reduce that, you should get 1 over 35. So 1 over 35 equals e to the negative 10x. And now look, you're solving for an exponent. Your unknown's up here in the exponent. Your base is e. So I'm going to take log base e of both sides. Whatever this base is here, that's what you want your logarithmic base to be when you do this. Okay, you bring down the whole right side, that's e to the negative 10x. Over here, you bring down the whole left side, which is 1 over 35. Squeeze that in there. Now, log base e does mean natural log of 1/35, and over here on the right side, whenever a base matches a base, everything cancels out except the exponent, so negative 10x. So now we type into our calculators the natural log of 1 divided by 35, and we get out negative 3.555. So negative 3.555 equals negative 10x. So now we're going to divide both sides by negative 10x. That would give us a positive 0.3555 equals x. Now you might not have rounded there on your problem, but that's fine. Still, you get the basic idea. Negative 3.555 divided by negative 10 does give you this for an answer. Wow, that was a pretty decent lesson. I mean, we covered it pretty quickly. I think that's the notes and the homework all in about 40 minutes, so not bad. Hope this is making sense, and we'll go on from there. Have a good day.